Let's have a crack at question 15 from the cross-topic review exercise. An arrow is fired from a point at a height of 1.5 meters, initial velocity of 12, an angle of 30, hits a target 1 meter above the ground. The path of the arrow is shown like this. Part A, show that the time taken is 1.3 seconds. If there's anything we know about the projectile questions, it's that we're going to keep the horizontal and the vertical separate, aren't we? Horizontally, we're going to use S equals UT. Vertically, we're going to use all the Suvat equations, because vertically we have acceleration is G downwards. So if we're going to treat horizontally and vertically separately, time taken, we don't know anything about that distance, but we do know there's a change in height of ½ meter. We know the speed at the beginning and we know the angle. So we actually do know vertically, we know that U is 12 sine 30. We know that S, that goes from 1.5 meters to 1 meter, so that's ½ meter. And we know the acceleration is 9.8 meters a second. Now all we've got to be super careful about here is signs. That was upwards at first, ends up lower, it's accelerating downwards. So I would make that positive, that negative, and that negative. And we want to find T. You go to your formula sheet and you find that the formula that links them is S equals UT plus ½ AT squared. So we've got minus 0.5 is 12 sine 30. Convinced it's 6, but my mind's going blank. 6. So 6t take, that one's negative, 4.9t squared, which is a quadratic. And on our exams, you rearrange that. And we don't have to be any more complicated than solving on the calculator, don't we? So menu, that one. So polynomial degree 2, 4.9 minus 6 minus 0.5, and we get an answer of 1.30, which is what we wanted, isn't it? So T is 1.3 minus 0.07, can't be negative, so we discount that. Part B of the question. Part B of the question. Find the horizontal distance travelled. Horizontal distance travelled. Well, the one thing we know about the horizontal motion is it's always, S is always equal to UT. So it's going to be S is equal to 12 cos 30, the horizontal component of the velocity multiplied by the 1.3 we've just found. So that's 12 times cosine of 30 times 1.3 is 13.5 meters. Find the speed when the arrow hits the target. Well, when it hits the target, the velocity is divided into two components. We have this horizontal component, which is still the same as it always is, the 12 cos 30. So we have, I'm going to call that, let's call that x and y. So x is 12 cos 30. 12 cos 30, 6 root 3. And I'll keep that as is for the time being, then we'll round later. Oh, I should have said they're components of the velocity as it hits the target. How are we going to find y? Y is one of the vertical quantities, so we're going to use suvat again. Y, vertically, we've got u is 12 sine 30, which is 6. We've got s is minus 0.5. We've got g is minus 9.8. And we want to find that value y is the final velocity there, isn't it? V equals y. I'll take those out of the way. So u, s, a, and v. V squared is u squared plus 2as, which is going to be 6 squared take 2 times minus 9.8, sorry, 2 times minus 9.8 times minus 0.5. 2 negatives make a positive. 2 times a half is a 1, so that's going to be 36 plus 9.8. 45.8, which means V is root 45.8, root and equals 6.8, and that's the y value. So why have we worked that out? The question C wanted the speed, it wanted that. The actual speed V combines those two components like you would in vector form, so it's the square root of the 6 root 3 squared and that answer squared. So it's the square root of that previous answer squared plus 6 root 3 squared. If I square that's 36 times 3 is 108. Square root of, let's just do it properly then, shall we? 6 root 3 squared plus 6.8 squared. So the square root of 6 root 3 squared plus 6.8 squared is that, which is 12.4, which is the speed when it hits the target. Part D, the angle between the velocity of the arrow and the horizontal. Well, that we can get from the diagram we've just drawn. The angle between the velocity and the horizontal will be this angle. I'm just running out of space at the bottom of the page there, so if I move that across, D, that angle is tan minus 1 of that y upon x, of that over that, opposite over adjacent, y upon x, which is tan minus 1 of the 6.8 divided by the 6 root 3. And that gives an answer of shift tan 6.8 6 root 3 33.2 degrees. which is a really classic projectiles question, working on this key idea here, that you keep the horizontal and the vertical separate.